October 14th, 2025. The Kupiansk tree line, 11:47 in the morning. A four-rotor FPV drone screams through cold October air at 140 kilometers per hour. The man watching through the goggles is 23 years old. His call sign is Marko. He flies for the Achilles Battalion. He is not targeting a vehicle, not a building, not a soldier. He is targeting a cable buried under dead leaves. The thermite payload detonates. White fire blooms in a 3-meter circle. The cable severs. 14 kilometers to the east, 3 Russian Lancet 3 loitering munitions already airborne simultaneously lose their guidance signal. They drift, they spin, they fall into Ukrainian counter-UAV nets. 90 seconds, start to finish. That was the first deliberate Ukrainian strike in this war, targeting the cable itself. Not the drones it guided, not the hub it connected, the cable. Before we explain how that 41-minute hunt on October 14th changed Ukrainian counter-Lancet doctrine for 2026, you need to understand why Russia ran that cable in the first place. By mid-2024, Ukraine had built one of the most effective electronic warfare corridors in the world. Radio frequency jammers saturated entire front sectors around the clock. Signal interception platforms patrolled designated grid coordinates continuously. NATO partners had funneled $2.3 billion in dedicated electronic warfare equipment into Ukrainian hands by January 2025. By the third quarter of 2024, radio-guided Russian drone systems in the Kupiansk salient alone were failing at rates exceeding 60%. If it broadcasts a signal, Ukraine could jam it. Radio frequency FPV drones. Jammed. Command and control radio links. Disrupted. Encrypted Russian tactical comms on standard military bands. Intercepted. Ukraine had erected a wall of electromagnetic noise that turned radio-guided precision strikes into a gamble Moscow could no longer afford. Moscow needed a solution that did not transmit. The answer was fiber-optic. A fiber-optic cable carries data as pulses of light through glass threads thinner than a human hair. It does not emit radio frequencies. It cannot be jammed from the air. It cannot be intercepted with conventional electronic warfare equipment. A drone guided through a fiber-optic tether receives real-time targeting updates through a connection that is, for all practical purposes, invisible to every Ukrainian EW system on the field. Russian engineers began deploying fiber-optic guided drone systems in the Zaporizhia sector in September 2024. By March 2025, the doctrine had spread to the Kupiansk front, the Avdiivka approaches, and sections of the Vuhledar corridor. The cables were buried where possible, threaded through drainage culverts, covered with camouflage netting on exposed sections. They ran from forward command posts to Lancet 3 drone launch clusters positioned as far as 14 kilometers behind Russian lines. The Lancet 3 was the weapon this fiber-optic network was built to protect. Weight, 12 kilograms. Wingspan, 1.2 meters. Warhead, 3 kilograms of shaped charge capable of penetrating 300 millimeters of rolled homogeneous armor. Cruising speed, 80 to 110 kilometers per hour. Maximum loiter time, 40 minutes. Unit cost, approximately $35,000. Ukrainian tank and artillery commanders rated the Lancet 3 the single most dangerous precision weapon system on the Eastern Front through the first 3 quarters of 2025. It had destroyed confirmed Ukrainian armor at a rate that forced emergency positional changes to heavy equipment deployment across multiple sectors. With fiber-optic guidance, it could not be jammed. With thermal camouflage on the airframe, it was difficult to visually acquire, before impact. With a 40-minute loiter window, it could wait. For most of 2025, it did exactly that, and Ukrainian forces on the receiving end had no reliable answer. The Achilles Battalion was established in January 2023 as a Ukrainian Special Operations Unit assigned to the Kharkiv Regional Defense Structure. By mid-2024, the unit had shifted its primary mission profile from close reconnaissance to counter-UAV operations, building deep institutional expertise in drone detection, drone hunting, and drone interdiction across variable terrain. By October 2025, Achilles operators had accumulated more than 200 documented confirmed drone-on-drone intercepts across the Kupiansk salient. 4 members of the unit began a standard route reconnaissance at 6:22 in the morning on October 14th. Their call signs, Marko, Sova, Vita, and Brat. They carried 2 Mavic 3 Enterprise thermal platforms, 4 FPV drones loaded with standard fragmentation payloads, and 2 thermite-modified warheads, a ruggedized laptop running Ukrainian-developed thermal overlay software designated Spider version 3.2, and personal sidearms. No fire support assigned, no armored vehicle. They moved on foot through a belt of oak forest on the Ukrainian-held side of the tree line. Routine mission, familiar terrain, zero expectation of what was about to happen. The thermal anomaly appeared on Sova's Mavic feed at 5:40 a.m. The Kupiansk tree line, viewed through thermal imaging in pre-dawn darkness, presents a predictable, radiative spectrum. Vegetation retains ambient heat overnight. Open ground cools faster than organic matter. The thermal contrast between tree mass and exposed ground is consistent and readable for any experienced operator. This signature was different. A buried fiber-optic cable, even when not transmitting, leaves a faint thermal trace. Military-grade insulation materials used in Russian Yaroslavl OFC-7 fiber-optic cable generate a marginally different radiative profile than surrounding Earth, a temperature differential of approximately 0.3 to 0.7 Kelvin, depending on soil composition, moisture content, and atmospheric conditions. Under most field conditions, this signature does not appear in any thermal detection manual. Under most conditions, it is invisible. But under specific conditions, clear sky, low wind, pre-dawn ground temperatures between -2 and -6 Celsius, it becomes detectable to an experienced thermal drone operator with enough field hours to recognize it. October 14th, the Kupiansk tree line. Temperature at 5:40 a.m., -4 Celsius. Wind speed 3 kilometers per hour, northwest. Sky clear. Sova had seen a similar thermal profile once before. A buried electrical conduit near the Bakhmut front in February 2024 had produced an almost identical radiative signature. She had noted it then as a curiosity. Now she flagged it to Marko as a possibility. Marko looked at the Mavic feed for 11 seconds. Then he said, "That's a cable." What Sova had detected was not a single cable segment. The thermal trace threaded through 600 meters of visible tree line before disappearing beneath an access road surface and continuing east into Russian-held territory. Full mapping required multiple Mavic survey passes at varying altitudes and approach angles. Each pass risked acoustic detection by Russian sensors positioned along the tree line. Each pass burned operational time. Time was the constraint that governed everything. Pre-dawn darkness, the window where drone operations could run without visual tracking by Russian ground observers, would last approximately 90 minutes from first detection. After 7:10 a.m., light conditions would make drone launches traceable to observation posts on the Russian side of the line. The team had 73 minutes. Vita ran the thermal overlay mapping, while Brat maintained 360-degree perimeter security from a concealed position 60 meters north. Sova flew 4 separate Mavic survey passes between 5:47 and 7:28 a.m. Each pass produced a 200-meter thermal map section of the cable route, accurate to within approximately 1 meter. She stitched the sections on the Spider 3.2 software, cross-referencing terrain elevation data to account for burial depth variations at creek crossings and drainage points. By 7:31 a.m., the team had a complete map, 14 kilometers in total, parallel to the tree line for its first 8 kilometers, then bending southeast toward what imagery analysis would later confirm as a forward Lancet 3 hub cluster in Russian-held territory. The cable fed real-time guidance to Lancet 3 platforms launched from 2 confirmed positions at kilometer markers 9.2 and 11.7 of the Russian side of the line. The question was not whether to strike. The question was where. Most of the 14-kilometer run was buried beneath packed earth and dry autumn debris. 2 sections crossed drainage culvert systems where the burial depth made a surface strike ineffective. 3 sections crossed small clearings covered with camouflage netting staked at 10-meter intervals. But at kilometer 7.4, the cable crossed 43 meters of open rocky ground at a drainage channel erosion point where topsoil had washed away. Here, the cable lay exposed, protected only by a single layer of netting. 43 meters of exposed line. This was the target. One problem: 2 Russian infantry observation positions flanked the tree line approximately 380 meters northeast of the crossing point. A Russian Orlan-10 surveillance drone was running a standard grid patrol over the sector on a repeating 8-minute cycle. During the northward leg of its patrol, the Orlan's optical payload pointed south, directly toward any FPV launch from the Ukrainian side of the tree line. Marko needed a blind window. He found it in the patrol cycle itself. During the Orlan's southward leg, the drone's sensor array faced away from the crossing point for approximately 90 seconds. From the moment it turned south to the moment it reached the edge of its patrol grid and swung north again. 90 seconds to launch, cross open terrain, and hit a target 3 centimeters in diameter, lying 400 meters away. Marko had flown faster intercepts. He had never flown a precision strike on a stationary linear target measured in centimeters rather than meters. The targeting discipline required for a cable strike was closer to competitive drone racing than to standard anti-armor doctrine. The margin for error was not measured in meters. It was measured in centimeters. He watched the Orlan complete 2 full patrol cycles, then a third. He timed each turn against the laptop clock. The cycle was consistent, 8 minutes and 12 seconds per full circuit. Southward leg, 3 minutes and 44 seconds. Window of non-observation at the crossing, 94 seconds. At 9:19 a.m., the Orlan began its 4th southward leg. Sova held up one finger. 90 seconds. Marko launched. The first FPV covered the 400 meters to the crossing point in 4.2 seconds at 140 kilometers per hour. Marko guided it through the goggles, watching the thermal overlay of the cable segment visible on the secondary monitor beside his right hand. He had the crossing point in the FPV camera. He had the cable shadow. He had the target. He missed by 3 meters. The FPV impacted the rocky earth at the eastern edge of the exposure zone. The thermite payload ignited, scorching a 1-meter radius of ground and briefly heating the surrounding rock surface to 1,100 degrees Celsius. The cable, 3 meters away, was unharmed. The Orlan completed its southward leg and turned north. The window closed. Russian acoustic sensors in the area registered the impact. The detonation pattern, brief, single point, low yield, was consistent with artillery scatter, a common occurrence along this section of the front. No Russian response was dispatched. The Lancet 3 hub remained operational. Marko had one FPV left. Here's the part that doesn't make sense on the surface. He did not launch the second drone immediately. He waited 22 more minutes, through 2 more complete Orlan patrol cycles, watching the Mavic feed with the patience of someone who had spent 14 months learning to wait. The thermite burn had done something he had not anticipated. The detonation shockwave had shifted the exposed cable segment at the crossing point by approximately 20 centimeters relative to Sova's mapped position. The blast had disturbed the staked netting, letting the cable settle 2 inches north of its charted line, 20 centimeters. At the speeds and angles required for the strike geometry, 20 centimeters was the difference between a hit and a miss. Marko recalculated. He ran his approach vector through the flight controller's simulation software 3 times. He calculated the thermal updraft from the scorched ground, now radiating residual heat above ambient, and its predictable effect on FPV aerodynamic behavior at low altitude. He adjusted his entry heading by 4 degrees, 4 degrees north of the first strike vector. At 9:41 a.m., the Orlan began its 6th southward leg. Sova held up one finger. The second flight lasted 11.3 seconds. The FPV approached on a heading 4 degrees north of the first strike, correcting for both the thermal updraft and the 20-centimeter cable displacement. Speed, 138 kilometers per hour. Marko watched through the goggles. He did not look at the terrain. He looked at a single point in space where 2 lines intersected: the cable's thermal profile and his calculated impact vector. The thermite payload detonated at 9:41 a.m. and 22 seconds. The Yaroslavl OFC-7 military-grade fiber-optic cable carrying real-time guidance signals for a Russian Lancet 3 drone hub, severed cleanly at kilometer 7.4 of its 14-kilometer run. What happened in the next 90 seconds has not appeared in any prior declassified Ukrainian military document. 3 Lancet 3 loitering munitions were active in the sector at the moment of cable severance. Their unit designations are redacted in the public release, but a separate Ukrainian SIGINT team positioned 4.1 kilometers north had been tracking their emissions since 9:14 a.m. All 3 were in active guidance mode, receiving real-time targeting updates through the now severed cable. When the link cut, they lost guidance. Simultaneously, a Lancet 3 without a guidance signal does not fall from the sky immediately. It continues on its last programmed heading. It continues until battery expiration, terrain contact, or interception. The 3 drones that lost their signal on October 14th drifted northwest, following their last heading vectors, without correction, without updated targeting, without purpose, directly into the coverage envelope of a Ukrainian Gepard 1A2 anti-aircraft system positioned 2.1 kilometers behind the front line. The Gepard crew acquired all 3 radar returns within 53 seconds of cable severance. Lock, burst, 4 3-round engagements from the twin 35mm cannon. All 3 Lancet 3 drones destroyed in the air. Total engagement time from cable cut to last intercept, 89 seconds. The math of what Marko's team had just accomplished took Ukrainian military analysts approximately 6 hours to fully process. 2 FPV drones. Total platform cost, $720. Thermite payload modification, $140. Total strike expenditure, $860. 3 Lancet 3 units destroyed in the air, $105,000 in Russian weapon systems eliminated. 1 fiber-optic cable section severed, 7.4 kilometers of Yaroslavl OFC-7 at current procurement pricing, estimated acquisition and installation cost, $180,000. Total Russian losses attributable to one $860 strike, $285,000. Cost exchange ratio, 331 to 1. No Ukrainian counter-Lancet operation documented anywhere in 2025 had achieved better than a 12 to 1 cost ratio. Electronic warfare suppression campaigns, counter-UAV air defense deployments, dedicated Lancet interception teams equipped with thermal scopes and shoulder-fired systems. Measured against the Marko operation, all of them looked like expensive solutions to a problem that had an $860 answer. Operator Marko gave a classified debrief to Ukrainian military intelligence on October 16, 2025. He spoke for 4 hours and 12 minutes. The declassified summary runs 47 pages. I went through all 47 pages of that debrief. Technical specifications, approach vectors, timing logs, atmospheric readings at the tree line. One line in the summary kept standing out. Not a tactical detail, not a technical specification. One sentence from a 23-year-old FPV pilot in an intelligence office 2 days after cutting a Russian cable with a thermite drone. He said, "We spent all of 2025 trying to shoot down Lancets. We should have been looking for the wire." That one sentence reframed everything Ukrainian counter-Lancet strategy had been built on. The formal Ukrainian counter-Lancet program through 2025 had operated on 3 parallel tracks. First, thermal interception. Shoulder-fired anti-air teams trained specifically to visually acquire Lancets in terminal dive phase. Second, electronic suppression. Attempting to disrupt Lancet guidance even after the shift to fiber-optic through signal environment saturation, targeting secondary radio systems on the platform. Third, air defense layering. Deploying Japad systems, Stugna P missiles, and Buk M1 batteries in overlapping coverage envelopes designed to catch Lancets before impact. All 3 tracks produced confirmed results. None of them were decisive. The shared assumption underlying all 3 was that the Lancet had to be stopped in the air. Marko's team eliminated 3 Lancets without firing a single round at any of them. Here's what that actually means. Russia's fiber-optic cable program was a doctrinal shift, not just a workaround. It changed how drone warfare is controlled at the operational level. If electronic warfare cannot jam the guidance signal and air defense cannot reliably intercept the platform before impact, the next layer of defense becomes destroying the infrastructure that makes the system work at all. This is not a new concept. Air campaigns target rail networks, power grids, logistics hubs. But applying that logic to drone guidance at 4-person squad level, improvised in a tree line in October, was something new. By October 20th, 2025, Ukrainian Ground Forces Command had received the Achilles debrief summary. An 11-officer working group convened in Kyiv. 4 signals intelligence specialists joined. Their mandate: formalize the Kupiansk methodology into replicable doctrine that did not require operators with SOVA's 14 months of thermal experience to execute. Here's the take that'll probably get us pushback. Ukraine was far too slow to get here. Fiber-optic drone guidance was publicly described in Russian military technical journals as early as 2022. Israeli defense contractors had demonstrated fiber-guided loitering munitions at the DSEI London Defence Exhibition in 2019. The thermal detection signature of buried military-grade cable under specific atmospheric conditions was physically predictable from first principles. It requires no classified technology to identify, only trained operators with adequate thermal drone field time. Ukraine had the equipment to detect fiber-optic cables thermally since mid-2023. Mavic 3 enterprise platforms were deployed in field use. Experienced operators like Sova were building exactly the pattern recognition library that made October 14th possible. What Ukraine lacked for 11 months was a command structure asking the right question. How do we break the connection, not just stop the drone? That question cost Ukraine 11 months. What is the Lancet 3 casualty count for those 11 months on the Kupiansk front alone? That figure is not in the declassified report. But it is the question that should have been asked in November 2024. The working group produced a classified document referred to internally as the Kupiansk Protocol. The protocol identified 4 structural vulnerability categories in Russian fiber-optic guidance infrastructure. First, thermal detection. The radiative signature Sova identified on October 14th is reproducible. A detection algorithm trained on the OFC7 thermal profile could identify cable routes with significantly less operator experience than Sova's 14 months on the thermal platform. The Spider 3.2 software team had a functional, updated algorithm in development within 6 days of receiving her field data. Second, moisture exploitation. Fiber-optic insulation degrades at sustained moisture contact points, particularly at water crossings, drainage channels, and subsoil water table intersections. Cables routed through these zones show elevated thermal signatures and structural vulnerability to thermite strikes at shallower burial depths than standard terrain installations. Third, junction point interdiction. The fiber-optic hub architecture requires physical junction points where multiple cable runs converge. These junctions are structurally fixed by hub hardware. They are larger, warmer, and easier to detect than individual cable runs. One junction point strike takes down every cable feeding through it simultaneously. Fourth, supply chain pressure. Russia does not manufacture sufficient military-grade fiber-optic cable domestically to sustain current operational deployment rates. Yaroslavl Optical Fiber, the primary domestic supplier, operates at approximately 60% of required military capacity. Third country procurement through Gulf intermediaries, the primary resupply channel identified in signals intelligence, carries an average delay of 73 days from order to frontline delivery. The strategic implication is simple. Cut cables faster than they can be replaced, and the resupply chain becomes the binding constraint on the entire Lancet 3 program. What do you think? Is treating cable infrastructure as a primary target a sign that Ukraine has fundamentally shifted its counter-drone strategy? Or is this a field improvisation that command structures will struggle to scale? The comments section has been full of that question since our September Lancet video. We want to know where you stand. The Achilles team held their concealed position in the tree line and waited. At 11:19 a.m., a Russian BTR-80 armored personnel carrier emerged from the eastern tree line, moving at low speed along a service track running parallel to the cable route. It stopped 200 meters from the crossing point at kilometer 7.4. 4 Russian soldiers dismounted, carrying cable maintenance equipment. Brat photographed them through a 70mm lens from 320 meters. The images were transmitted to Ukrainian military intelligence at 11:31 a.m. Technical analysis confirmed the soldiers were carrying Yaroslavl OFC, 7 splice repair kits, military-grade field hardware for frontline fiber-optic cable repair. The same kit had been documented at 2 prior Russian cable repair operations in the Zaporizhzhia sector in June and August 2025. The repair team's presence resolved the remaining uncertainty. Infrastructure repair teams are dispatched for confirmed breaks, not suspected interference, not signal degradation that the cable's built-in signal repeating architecture might route around. A physical BTR-80 deployment with splice equipment means a physically severed cable requiring manual reconnection. The presence of the team was proof that the second thermite strike had achieved complete severance, not partial damage. The cable was cut. The repair took 7 hours and 40 minutes. During those 7 hours and 40 minutes, Ukrainian military intelligence recorded 0 confirmed Lancet 3 strikes in the Kupiansk sector. The preceding 30-day average had been 4.7 confirmed Lancet strikes per day in that specific area of operations. 4.7 strikes per day. 0 on October 14th after 9:41 a.m. A single cable severance operation conducted by 4 soldiers with $860 in materials and 2 FPV drones shut down a Russian Lancet 3 hub for nearly 8 hours. Put yourself in the position of the Ukrainian artillery commander who read that number in the after-action summary. 8 hours without a Lancet strike in a sector that had been taking 4.7 per day. What would you have done differently about your armor and artillery positioning if you knew 8-hour windows were achievable on demand? That question drove the formation of the Kupiansk Protocol Working Group. Team Marko or Team Doctrine? Comment which side you're on. Was this 4-person team proving that Ukraine's formal counter-UAV program had been focused on the wrong problem for 11 months? Or is improvised field innovation always going to outpace institutional doctrine in a fast-moving technology war? And this is simply how good doctrine gets written? Comment yes. If you think cable hunting becomes Ukraine's primary counter-Lancet tactic by mid-2026. Comment no if you think Russian countermeasures will close the thermal detection window before Ukraine can scale it. We read every one. Marko returned to operational rotation on October 22, 2025. He and Sova received internal citations for operational distinction from Achilles Battalion Command, dated October 25th. Both citations remain classified. Their full names are not in any public record. The fiber-optic cable at kilometer 7.4 of the Kupiansk tree line was repaired by Russian engineers and restored to operational status at 7:28 p.m. on October 14th. New Yaroslavl OFC 7 splice materials flown forward from a Russian logistics depot at Veluki were installed and tested. The Lancet 3 hub went back online, but the vulnerability it had revealed was permanent. On November 3, 2025, the Ukrainian Ministry of Defense released a declassified operational summary of the Achilles mission. The release was deliberate. Ukraine wanted Russian engineering units to know that fiber-optic cable was now a targetable infrastructure class. The psychological effect was calculated. Every Russian cable installation now had to account for thermal detection risk. Every cable route had to be evaluated for exposure windows. Every hub location had to be reconsidered in light of junction point vulnerability. Russia now had to defend its cable infrastructure. By November 15, 2025, Russian engineering units in the Kupiansk sector had begun adding additional burial depth to new cable installations, increasing construction workload per kilometer by an estimated 340%. Russian fiber-optic procurement requests, forwarded through Gulf intermediaries, increased 60% over the October baseline, according to European signals intelligence assessments shared with NATO partners. The unit price of Yaroslavl OFC-7 cable on monitored third-country procurement markets increased $2.40 per meter between October 15th and November 30th as Russian demand surged. Russia heard the message. By January 2026, Ukrainian counter-UAV units across 5 front sectors were running dedicated cable hunting operations using modified Mavic 3 enterprise platforms loaded with Spider 4.0, a thermal detection algorithm trained on the OFC-7 radiative profile first identified by SOVA on October 14th. Development time from field identification to functional operational algorithm, 34 days. In the 4 months following the Kupiansk operation, Ukrainian cable hunting teams documented 23 confirmed fiber-optic severance strikes across the Eastern Front. Estimated Russian replacement cost attributable to those 23 strikes: $4.1 million in cable procurement and installation. Total Ukrainian FPV expenditure for all 23 operations, approximately $19,000. That is the doctrine Marko wrote with an $860 strike on a 3-centimeter cable in a Kupiansk tree line. If you want to understand how the Lancet 3 threat evolved to the point where a fiber-optic guidance network became necessary, how Russia adapted its drone program after Ukraine's EW successes through 2023 and 2024, that breakdown is in the description below. It is the direct context behind why October 14th was possible and why the doctrine it produced matters for everything on the Eastern Front in 2026. Subscribe if operational breakdowns like this are what you are here for. We cover how wars actually work, not how press releases describe them. October 14th, 2025. 41 minutes of waiting. 11.3 seconds of flight. 89 seconds of consequence. $860. 3 Lancet 3 drones eliminated without a single round fired at any of them. This is how wars change.